Hello everyone, welcome back to our channel Maths Geek. I'm Chandan Soni. This is lecture 4 on differentiation. In today's lecture we are going to study derivatives of standard functions. And we know that derivative is denoted by dy by dx, that is change in y upon change in x. So y can be any function. So the first standard function we have is x raised to n. So derivative of x raised to n with respect to x is given by n into x raised to n minus 1. So what happens over here? This n comes down and gets reduced by 1. It jumps and gets reduced by 1. Second, derivative of a raised to x is given by a raised to x into log a. A raised to x remains as it is, okay? Gets multiplied by log a. So derivative of a raised to x is a raised to x into log a. That is change in a raised to x with respect to x is a raised to x log b. Next one, derivative of e raised to x, that is change in e raised to x with respect to x is e raised to x. So function remains as it is. Derivative of e raised to x is e raised to x. Fourth one, derivative of any constant is 0. For example given, if I have to take a derivative of number 5 is a constant, it will be 0. If we take derivative of number 1000, it will be 0. So derivative of any constant is 0. Fifth one, it's not a standard function, still you should know what is derivative of x. Derivative of x with respect to x is equal to 1. How? If suppose I am using the derivative formula for x raised to n, we know that derivative of x raised to n is n into x raised to n minus 1. Okay. In this case, when I just write x, what is x? X raised to 1. Okay. So using this formula, if I differentiate x raised to 1, so what we get? Derivative of x raised to 1 is 1 into x raised to 1 minus 1. So instead of n, we have 1 over here. Okay. So n into x raised to n minus 1. So 1 into, what is x raised to 1 minus 1? That is x raised to 0, and we know that x raised to 0 is 1. So 1 into 1, that is 1. So derivative of x with respect to x is 1. So we have written the formulas for derivative of x raised to n, derivative of a raised to x, derivative of e raised to x, and derivative of a constant. Okay. Next one, we have derivatives of trigonometric functions. Derivative of sin x is cos x. Derivative of cos x is minus sin x. I'll write the derivative formula in 2 sets. Next, derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of sec x is sec x into tan x. Derivative of cosec x is minus cosec x into cot x. If you see properly on the left side, we have derivative of sin x, tan x and sec x. Derivative of sin x is cos x, derivative of tan x is sec square x, derivative of sec x is sec x tan x. On the right section, if you see, we have derivative of cos as minus sin x, derivative of cot x is minus cosec square x, derivative of cosec x is minus cosec x cot x. So to remember, if you see, all the functions over here, they start with the letter C. Okay, so remember that derivative of cos, cot and cosec are always negative. Derivatives of cos x, cot x, cos x, they are negative. That is minus sin x, minus cosec square x, minus cosec x, cot x. Now, we will verify all this derivative formula using first principle. Okay, we know that I have written on the screen that d by dx of sin x is cos x. Let's verify this by first principle. So our function is sin x. So for first principle, I'll also need f of x plus h. What is f of x plus h? Sin x plus h. So as per first principle, what is f dash of x? F dash of x equals to limit h tending to 0 f of x plus h minus f of x upon h should be limit h tending to 0 sin x plus h minus sin x whole thing divided by h. If you look carefully in the numerator, you will see that we have something of the form sin c minus sin b. Instead of c, we have x plus h. Instead of b, we have x. So what is sin c minus sin d? 2 cos c plus d by 2 into sin c minus d by 2. So let's apply this trigonometric formula in the next step. So what do we get is 2 cos c plus d, that is x plus h plus x upon 2 into sin c minus d, that is x plus h minus x upon 2 whole thing divided by h. I can just draw a box over here. We'll draw a box over here. Okay. Now let us simplify the numerator. Limit h tending to 0 2 into cos 2x plus h by 2 into sin, if you see, x gets cancelled, h by 2 whole thing divided by h. In the numerator we have h. We will try to eliminate that. How that can be done? We know that limit h tending to 0 sin h upon h equals to 1. So we will try to keep this h with sin h by 2 and we will eliminate that. So limit h tending to 0 2 cos 2x plus h by 2 into sine h by 2 whole thing divided by h. So I need h by 2. I'll divide this by 2, so I'll multiply 2 over here. Now what do we get is that sine h by 2 and h by 2, they form a set. The limit of that is 1. So let us simplify it further. Limit h tending to 0. 2 cos 2x plus h by 2 into limit h tending to 0 sine h by 2 upon h by 2 into 1 by 2. Now apply the limits. So what do we get? 2 cos 2x by 2 into, this is 1, into 1 into 1 by 2. 2 to cancel. Okay. And in the cos part, this 2 and 2 gets divided. So we are left with cos x into 1. What do we get? Cos x. So our function was sin x. The derivatives by first principle what we got is cos x. So it is verified using first principle that derivative of sin x with respect to x is cos x. Similarly, we can verify all the other standard functions for their derivatives. Okay. In the next class, we will do derivatives of a sum, derivatives of difference, and we'll solve some problems based on standard functions. Till then, stay tuned. If you like the video, click on like button, share and subscribe so that you don't miss any of my future videos. Thank you.